Hello students, myself Professor Ankur. Now we are going to discuss the topic of diode clipper circuits from gate theory session and the main topic of analog circuits. In the previous session, we have discussed how a diode is connected for positive clipping with simple circuits involved, and we have considered both the behavior that a diode is ideal and a diode is practical. We have also seen few examples with use of battery. And now we are going to continue with the head. So if you observe the circuitry carefully, we are having two diodes. One diode for the positive bias circuitry and the other diode for the negative bias circuitry. We had seen a small discussion regarding the same circuitry in the previous session. We are going to have an elaborate discussion now on the same circuitry. So let's see what happens in the positive bias circuitry. So if you observe carefully, there is a battery of V volt attached to a diode via R, and the input given will be a sinusoidal function. So if I assume V as any potential which is a fixed value, let's say 2 volts, under that situation the anode of the diode will be at 2 volt. So because of this, till the time in the positive half cycle the input reaches 2 volt, the diode will be forward bias. If it is forward bias, it will work like a closed switch. Input will reach the output. But once the input crosses the level of 2 volt, you will find that a diode will work like an open switch. And hence, the output VO will retain the value of V. Now, what will happen under negative half cycle? In the negative half cycle, the input is going to make anode terminal negative. So for the entire half cycle, the diode is going to be forward bias. And since the diode is forward bias, it will work like a closed switch. And if it is a closed switch, the input will reach the output terminal. And that's the reason you retain the entire negative half cycle. If I just make a small modification in the first circuitry by reversing the battery, the impact can be seen as a second circuit, where if you observe, only the lower section of the signal will be retained and the top section of the signal will be clipped. And if your observation is very sharp, majority portion of the signal is getting clipped and only a very small portion is left out. This is all because of a small change in the circuitry. So this is how, once I change a battery potential or the way in which the battery is connected in the circuitry, the input waveform gets clipped and the output waveform gets modified. Here we are discussing a negative clipper. So when we talk about a negative clipper, the main target is to clip off the negative half cycle. So if you see the arrangement carefully, when I give an input as a sine wave, the observation will show that in the positive half cycle, the diode will be reverse bias. And since the diode is reverse bias, it will work like an open circuit. And hence you will find the input is getting passed to the output terminal. So I can easily say VO is equal to Vin. In the negative half cycle, the diode will work under forward bias and it will work like a short circuit or a closed switch. Hence, you will find VO is equal to 0 volt. Now why VO is 0? Because we are considering the diode as ideal diode. So under ideal behavior, the diode will work like a closed switch under forward bias. And the drop across diode will be taken as 0. And hence VO will go to 0 volts. The impact can be easily seen on the output waveform, where you can see the retention of the positive cycle and the negative cycle gets clipped off. So if you observe carefully, this is defined as negative clipper. And obviously, we have considered here a diode under ideal condition. Now if you observe, when I go for a practical condition, if you observe carefully, the diode under practical condition will show you a drop of 0.7 volts under forward bias. So if a diode is forward bias, it will have a drop of 0.7. But if you compare the previous circuitry and the second circuitry and the third circuitry, The first circuitry was having ideal diode, the second circuitry is having a practical diode, and the third circuitry now is showing you impact of battery. So when you compare the previous circuitry and the coming circuitries here, they're actually the same. The only thing is the way of discussion. Here in the top section, if you observe, the diagram is assuming that a diode is practical. And that's the main reason. Instead of getting practical value as 0 volt, which was discussed in the previous circuitry, you'll get it as minus of 0.7. And this is all because when the negative half cycle of the input is coming into picture, the diode becomes forward. And when the diode becomes forward, the potential across the diode will be plus 0.7, where plus is corresponding to the anode and minus is corresponding to the cathode. But if you observe carefully, the output is measured across the diode, where the plus polarity of the potential is at the lower point and the minus is on the top point. So it is as good as when you measure the value of VO, you will get a negative potential. And that's the reason the VO comes out to be minus 0.7. If I just spew you an impact of biasing potential, the impact of biasing potential can be easily seen in the waveform itself. Where if you observe, during the positive half cycle of the input, you get the entire positive cycle at the output point. And if you observe, the positive cycle is unclipped. But when we talk about the negative cycle is getting clipped. Now this is all because of the conduction state of the diode. The conduction state of the diode is now controlled with the help of a battery. If you see carefully, the anode of the diode is connected to a negative voltage. So whenever the cathode terminal goes to a voltage which is less than the anode, the diode will work like a closed switch. And once it works like a closed switch, it will make the output as good as V out equal to minus of V bias under ideal situation, and under practical situation it will be minus of 0.7 minus of V bias. So if you observe, battery does create a huge impact on the clipping level of the signal. Thank you.